Kia ora koutou. This question is for Hugo, and it's a differential equation from March 2020. So this is one of the papers that I think didn't get sat because of COVID. It's a really nice example of how they've worked on the new stuff in the curriculum in not that obvious a place. And I'm talking about an inverse tan integral or derivative. So we've got a dE where we're told that this is dy by dx. And we're told that when x is 1, y is equal to 0. First, we have to solve the dE, and then we have to say what happens to y as x tends to infinity. And you can see most of the marks are in the first part there. So let's just start off by writing it down and then separating the variables. So we've got 1 plus 4y squared over e to the x is equal to dy by dx. That gives me, let's see, which way am I going? I'm going to have... Oh, this is weird. This is e to the negative x times dx. Sorry, had a complete brain moment there. That's what we've got on both sides so far, and we're going to integrate both sides. On the left-hand side, that's pretty easy. We're going to get negative e to the negative x. I'm going to put my arbitrary constant over here, and now this is equal to something to do with tan. Let's just take a look at how I can rewrite it. I've got 1 over 1 plus 2y all squared dy. So if you have to do this with a u substitution, do that, but you shouldn't need to do that at this stage in the year. If you're feeling wobbly on this, go and search up the video that I did with lots of different inverse tan derivatives and integrals. So I think it's called something like inverse tan derivatives, but ask me if you can't find it. So let's just look at what happens if we start off with that integrating to give me tan inverse of 2y, and then we'll put down our plus c. If I differentiate this, so just come over to the side and look at what happens if that's our starting point. Dy by dx won't be exactly what we want because it's going to be 1 over 1 plus the thing squared, right, the inside function squared, but by the chain rule I have to times by 2. So the problem here, and Hugo, where I think things went wrong, is that if you don't remember that that's what you get when you differentiate this, you won't make that adjustment in your integration. So in here we need to have 1/2 tan inverse of 2y plus c. The next thing that I can do is substitute in the x and the y. I don't have to do any rearranging first. So when x is equal to 1, y is equal to 0. That gives me negative e to the negative 1 is equal to 1/2 tan inverse of 0 plus c, giving us, so the angle whose tan is 0 is just 0, negative 2e to the negative 1. That's not right. It is simpler than that. It's just negative e to the negative 1 is equal to 0 plus c. Right, so where does that leave us? Well, back here, we've got negative e to the negative x is equal to 1/2 tan inverse of 2y minus e to the negative 1. What was I asked to do? Let's see. We have to solve the differential equation, obtaining an expression for y in terms of x. So we've got a wee way to go yet. I'm going to add this onto both sides. That will give me e to the negative 1 minus e to the negative x is equal to tan inverse 1/2 tan inverse of 2y. 2e to the negative 1 minus 2e to the negative x is equal to tan inverse of 2y. Now I'm going to undo the inverse tan by taking the tan of both sides. So we get tan of 2e to the negative 1 minus 2e to the negative x is equal to 2y, giving me a final answer of y is equal to 1/2 times tan of 2 over e minus 2 over e to the power of x. It's fine to leave it in this form here. You don't have to do what I did in that very last line, but you have to get down to an expression that has got y as the subject of it. Now, the last thing that we've got to do here for the last mark is to say what happens to y as x tends to infinity. So as x tends to infinity, e to the negative x is going to go where? Well, here's my graph of e to the x, of e to the negative x, and e to the negative x is going to go to 0. So that means that as x tends to infinity, y is going to tend towards 1/2 tan of 2e, because this bit here is going to tend to 0. And that's my final answer. Okay, Hugo, really nice question. Just send in any more that you guys have got problems with.